We're now going to move on to studying exponential equations and solving exponential equations. To do this, we're going to talk about a basic idea. It's very intuitive but very powerful and allows us to solve a lot of these exponential equations as we move through this chapter. So if we have an equation a to the x power equal to a to the y power, if those bases are the same, then we know those exponents must be equal. So then we can say that x equals y. So informally, if we have two exponential expressions equal to each other and they have the same base, then we can set the exponents equal to each other. Okay, so if we look at example 4a, we want to solve this exponential equation. And we know it's an exponential equation because the variable appears in the exponent. Not every equation that has exponents is an exponential equation, but because the variable is up in that exponent, it's exponential. So in order to solve, we know we need to isolate the variable. So in order to isolate the variable, we're going to have to get that variable out of the exponent if we're going to isolate it. So this property that we just discussed will allow us to easily do that. So if we look at the left and the right side, the left side is written with a base of 2. Well, if we look at the right side, 4 can certainly be written with a base of 2, so we could rewrite it as 2 squared. So if we rewrite the left side, 2 to the x minus 3, and write the 4 as 2 squared, now we can use this property. If the bases are the same, the exponents must be the same. So then that exponent comes out, that variable comes out of the exponent. So x minus 3 equals 2, and then add that 3 over, and there's your solution 5. Let's look at part B. Here we have 1/5 equals 5 to the 1 minus 2x power. So if I look at the left and the right sides, I can see on the right side I have a base of these exponent, a base of 5, and then on the left I've got a 1/5. Well, we know that 1/5 is the reciprocal of 5, and in order to indicate reciprocal, we use a negative exponent. So if I rewrite that 1/5 as 5 to the negative 1 power, I'll have 5 to the negative 1 equals 5 to the 1 minus 2x. Now the bases are the same, so I can set those exponents equal to each other, which will allow us to isolate that variable and solve. So now we can say negative 1 equals 1 minus 2x. So we'll subtract the 1 from both sides, so negative 2 equals negative 2x, divide by negative 2, and we get x equals 1. Part C, we have 64 to the 5y equals 16 to the y plus 1. Now if we look at the two left and right sides, both have an exponent on them. The bases are different, so we want to see, is there a way to write 64 and 16 with the same base? Well, conveniently here, we know 64 is a power of 2, and so is 16. So we can rewrite 64 as 2 to the 6th power, so we could write it as 2 to the 6th to the 5y. And then 16 we know is 2 to the 4th. So this is 2 to the 4th to the y plus 1. So now we have a power of 6 to another power of 5y, so we multiply those exponents, so this will give us 2 to the 30y. And here we have 2 to the 4th to the y plus 1, so we multiply the 4 times the y plus 1. So that'll give us 2 to the 4y plus 4. Now our bases are equal, so we can set the exponents equal. So we can say 30y equals 4y plus 4. And now the variables come down out of the exponent, so we can easily isolate it. So we subtract the 4y from both sides, so we have 26y equals 4. And then we divide each side by 26, so we have y equals 4/26, and reduce that to 2/13.